Now that we've spent 3 videos actually integrating prototypal inheritance into our JavaScript code, I want to take a step back and explore what's going on behind the scenes with the code that we're already writing. So in this one, we're going to start off with a single slide. We'll go through a visualization of what's happening, and then we'll get back into the code and experiment with a few things. So right here, we have our person constructor. The person constructor function has the prototype property. And on the prototype property, we chose to set up 2 things. In this example, get bio and set name. This is the stuff that we already have in place. Now, we also know how we can create multiple instances of person by using the new operator with the constructor function. We can create one instance of person over here called Clancy. We can create another instance over here called Alexis. Now, what we don't know is how these end up getting linked to the prototype property. All I know is that if I create a new person, I have access to get bio and set name. What's actually happening, though, is pretty interesting. Now, this is not an accurate depiction of what's actually going on here. Right now, we just have a generic arrow pointing from one thing to another. Let's go ahead and replace this person instance with a more accurate depiction of how the relationship is set up. So I'm going to remove everything from the left-hand side, although I'll keep the stuff on the right-hand side so we can compare and contrast. What's really happening is very similar, but with one missing detail. Right here, we have a more accurate picture of what's happening when we're using JavaScript and prototypal inheritance. Now, on this object, we still have the properties we set up. We still have first name, last name, and age. These are things that we, as the developer, created. Down below, though, we have something brand new. This is known as the prototype property. The prototype property is a property for internal use only, meaning that you're not going to see it if you try to access it on the object. But this is what creates the relationship between your instance and the methods that we're able to access. So the same thing is true with our other instance, obviously. So let's go ahead and switch that over as well. I'm going to remove the old example and bring in the one that correctly demonstrates what's happening. Here, all of the instances have a prototype property. That is what links them to the shared set of methods. Now let's go ahead and wrap up this slide by taking a look at a code example and figuring out how it fits in with the visualization up above. So let's start with the following. We're going to create a new person, and we're going to store that new person under a variable called me. For the moment, let's forget that we set up the likes array. We just have first name, last name, and age getting passed in. Now, behind the scenes, what's really happening is that me.prototype, this prototype property, it's getting set equal to the person constructor function's prototype. So this is what creates the relationship between me, the instance, and person.prototype, where all of our methods happen to be defined. Now let's see what happens when we start accessing things off of me. Down below, we're going to access me.firstname. When this code runs, it looks at person instance. It sees if there is a property that matches up with first name. There is. The string value is Clancy. So the end result of this line would be that Clancy prints. Now let's look at another example. Down below, we call me.getBio. When we use me.getBio, it's still looking at the person instance. This is where it starts. It looks for a property called getBio on person instance. It does not find one. If it found one, it would have used it, but it didn't. So what does it do? It looks to see if there is a prototype set up. In this case, there is. So it goes up the prototype chain, it follows the arrow, and then it looks here for what it needs. In this case, getBio. Does it find getBio here? Yes, it does. So this is how we are able to access getBio from an instance of person. It is because of this internal property prototype, and that creates the relationship we're seeing here. Now, what would happen if we tried to access something like me.testing? Well, it would look in the person instance for a property called testing. It's not going to find it. Much like it did for getBio, it's going to follow the prototype chain. It's going to go up over here looking for testing. This time, though, it's also not going to find it. Testing doesn't exist. So the end result is that we're going to get undefined. So we start looking here. We move up the chain, looking here as well. If we find it in one of those 2 places, great. We use whichever one we find first. If we don't find it at all, that's fine too. We just use undefined. What I'd like to do now is take this back into our code examples so we can mess around with how this relationship is going to affect the applications we've written. So let's jump back into Visual Studio Code. We're back in VSC, and I want to kick things off by talking about that person.prototype object a bit more. We know that all of our instances, in this case me and person2, link to that person.prototype object. It's important to note that any changes made to that object will be reflected in all of our instances, even if the change is made after the instance is created. So right here, between where we create and use person2, all I'm going to do is set person, uppercase P, dot prototype, dot get bio equal to something else. Let's go ahead and use the function. And all we're going to do is return a string, testing, testing. So this is going to show up for this call, even though we've configured prototype after the person instance was created. It does not matter when things were initialized. The change is indeed made, and it's made before we actually call the method. Now, for the first instance, we will get the same behavior we got before. Later on, we change it. And for the second instance, we should get the changed behavior. I'm going to save person and run it from the terminal, node person.js. And what do we get? We get Alexis is 27 with her message for the first instance, and we get testing for the second one. The reason that I'm bringing up this is because it works a bit differently than other languages. So if you come from a Java language background or a C++ background, you actually do have things copied over as the instance is created. This is not the case with JavaScript. It simply links to the prototype. Any change made to the prototype will be reflected in every single instance. All right, now that we've seen that, we can go ahead and remove that little example. It's not going to stick with us as we build out our application. It was just used to demonstrate a purpose. The one last thing I want to explore is that property shadowing we were talking about, where if a property exists on the instance, it's going to be used even if it also exists on the prototype. To see this, all we're going to do is tweak me. So right here, after we create me, but before we use it, I'm going to set me dot get bio, so directly on me, equal to a function. Once again, let's just create some sort of function that just returns a static string. This is fake, for example. So what's going to happen when we run this program? Well, the best way to figure out what happens is by running it, and then we'll analyze the exact process that's taking place. Over in the terminal, I am going to run the script. And as you may have suspected, we're getting this is fake for the first one, and we're getting Clancy is 51 for the second. So in this case, we are setting up a new property on our instance. So when we access getBio down below, it first looks on me. Does it exist? Yes, it does. So it uses that function and never gets a chance to go up the prototype chain. Now, it's important to note that the change we made to me had no effect on person2. This is a completely separate instance. So by setting the instance property up above for this one, we are not changing the behavior down below. We are still able to correctly call getBio seeing our message since we've never set up the getBio instance property. The only one we have is on the prototype for this example. So it first looks at person2. Does it have getBio? Nope. So it goes up that prototype chain and it looks at person.prototype. Does that have getBio? Yep. So it goes ahead and it uses that function. Now, a lot of the stuff that we just explored isn't necessarily going to come up day to day. Typically, we are not going to find ourselves taking advantage of features like this or features of changing the prototype after instances are created. All of that is explained just to give you a complete picture. It's important to know, otherwise you might run up against some very strange issues. Code that would seem to work one way works another way. In the beginning of the section, I also mentioned that another interesting thing about prototypal inheritance and why it's important to know is that it's used extensively behind the scenes by the language. For example, down below, we've created plenty of strings before. I might have a string Andrew, and we've also used methods like toLowerCase to manipulate those strings. In this case, I would get back the lowercase string Andrew. The question is, how are we able to access using dot notation a method on a string when typically this is reserved for objects? Well, the truth is that almost everything is indeed an object in JavaScript. So we're going to go ahead and jump right into the next video and see exactly what that means and how it plays out. By the end, you'll understand exactly how code like this actually works. We're going to remove this line, save the file, and I'll see you in the next one.